Welcome back, everyone. It's been a great morning for our conference today, and it will continue to be great. Let's introduce our next company. We have Red Paramount Iron Ltd, an emerging private steel feed production company. It's developing the first fully integrated green steel production in North America. Through the utilization of its high-quality iron ore resource, the Lac Virot Project will be the first fully integrated green steel feed production facility of its kind, setting a new standard for the industry with a competitive advantage in the market. The development is located in Newfoundland and Labrador, Canada, in a strategic location where surrounded by large-scale iron ore mines and has immediate access to $3 billion worth of infrastructure. Red Paramount is seeking to raise seed capital to complete pre-development workup to the start of project construction. Today, we'll be speaking with Farzad Nader, the COO, a true visionary in the resource development space with over 25 years of experience. His extensive expertise spans across various continents, including Canada, US, Mexico, South America, and the Middle East. With a diverse background, Farzad brings a unique perspective to the table and has been instrumental in the development of natural resources globally. Farzad's impressive educational background includes 3 master's degrees. He holds a master's in civil engineering from KMP University in Technology in Iran and a master's in environmental engineering from the University of Alberta. He also graduated from the executive MBA program at Simon Fraser University in Vancouver. Currently, Farzad serves as the co-founder and COO of Red Paramount Iron, a company that's revolutionizing the steel industry by developing the first fully integrated green steel feed production. With this extensive knowledge and experience, he's driving the company's mission and revolutionizing the steel industry by creating sustainable, eco-friendly solutions. Farzad continues to make waves in the resource development industry and pave the way for a greener future. It's my pleasure to introduce Farzad to the Emerging Growth Conference. Welcome.
Good morning, and thanks, Anna, and thanks everyone for joining us today. It's a pleasure to be here, and I appreciate your time. We are the only private company presenting today, and I'm happy on behalf of Red Paramount management team to present Lac Virot Project for the first time here, which is the first fully integrated steel feed development in North America. But first, let's go through the usuals, which is a disclaimer. You can read this from our website, but usually they're all the same. And it's important as I would be making some forward-looking statements. Here's the opportunity. The company is seeking to raise $30 million in capital in stages in the next 2 years to complete pre-development work up to final investment decision. It is going to be a pre-IPO stage capital raise, so it has early stage participation advantages. The project will be built in stages with very low execution timeline, and very short execution timeline and very low capital cost. And there's also a strategy in place to take this project to execution and production without significant existing shareholders' dilutions. The company has significant advantages compared to peers globally. We have a strategic decarbonization roadmap. The main advantage for our project is having a high-quality iron ore, magnetite-rich iron ore, and also access to $3 billion worth of existing infrastructure, which includes immediate access to rail, port, and very low-cost green electricity. When we are in production, we will have an equivalent to 3.3 million tons per annum of carbon emission reduction, which make the production eligible to access to carbon credits, which also be a source of revenue in the future. Before we dive to the project, I'd like to talk about the steel industry in general and draw your attention to where the steel industry is currently. the industry is one of the dirtiest industries in the world. It is responsible for 9% of global carbon emission and is considered one of the most energy-intensive industries in the planet. Around 77% of global steel production uses coal. It's a very dirty, full of carbon components that produce around 1.8 to 2.2 tons of carbon emission or CO2 for every ton of steel produces. For every ton of steel that produces using coal, around 800 kilograms of coal is being used. The other 23% of global production uses natural gas, and it has a slightly lower carbon emission. On an annual basis, the steel industry, as of 2020, produced 2.4 billion tons of carbon emission, which is a significant contributor to global warming. The industry is going through significant revolution, sustainable revolution, going away from coal, a paradigm shift to use renewable components, including hydrogen. To address the global warming, International Energy Association net zero emission has set targets for iron ore and steel industry. The target for 2050 is to bring the carbon emission from around 2.2 tons per steel, 2.2 tons of carbon emission per steel, to around 0.12 tons of carbon emission per steel. With the capacity increase, with the demand increase in the next few years, there is a shortage of 130 million tons of steel we are facing from now to 2030 and 2050. And Red Paramount is projecting to produce 1.8 million tons of green steel in upcoming years to assist with the shortage of green steel production globally. In the next stage, I'll talk about what is happening globally. There are around 23 companies globally going away from coal, using hydrogen and developing what is called H2DRI route, which is using hydrogen and eliminating coal from this process. Red Paramount Iron is the only private Canadian company that's leading the way. There's another company in Canada, ArcelorMittal, the global steelmaker giant, is planning to produce 2.5 million tons of steel. But Red Paramount is going with a smaller but a stepwise approach for development of our green steel production. Globally, Germans and Swedish are paving the way. They're way more advanced than everyone else. But other companies in Australia, in Belgium, in Netherlands, in UK, and in Canada, we're also following the developments. Governments are also doing significant work to assist the decarbonization of the steel. 18 countries whose economies account for 70% of global GDP have developed strategies for deploying hydrogen and make sure that decarbonization of the steel industry is happening. Canada has implemented strategies to produce 20 million tons of green hydrogen and allocated significant net zero funds for industries that are trying to reduce carbon emission in the next few years. The US has introduced Inflation Reduction Act for hydrogen. And in 2022, a production tax credit of $3 per kilogram of hydrogen introduced in the US, allowing decarbonization of iron and steel industry in the US. EU or European Union has also put forward a framework to support production of low carbon hydrogen and help decarbonization of the steel industry. Hydrogen-based DRI is the future of steel production as is being supported globally by governments, by universities, by private and public investors. The next slide talks about some of the challenges. At the moment, the price of hydrogen is high. It is not competitive with the price of coal. And there are a few things happening in the market to address this. The market is shifting, the steel industry market is shifting its supply chain by co-locating steel production facilities near rich, high-quality mines where there is access to green electricity, green, low-cost electricity to make this competitiveness happen and make sure that the sustainable approach for green steel production is cost competitive with carbon based steel production. So a lot of movement is happening in the industry, but what is obvious is the cost of electricity and hydrogen, which accounts for around 40% of the cost of steel production or green steel production, is a major component. And also the cost of raw material and access to high quality raw material is a major component, which with Paramount Iron has all those enabler components to be producing the first fully integrated green steel production in North America. The next slide, I'd like to go back and talk about the project. The project is led by company founders, myself and Sherwin. Between us, we have around 50 years of resource development experience. We're supported with a seasoned group of advisors in many fashions, from mining engineers, operation experience, steel production experience, and also we have some politicians that are helping us and advising us to maneuver through social and environmental aspect of the project and make sure that we can deliver the first green steel project in North America. As Anna mentioned, the project is located in Newfoundland and Labrador. It is located in Labrador West. It is located in a circle of, with a radius of 30 kilometers that produces 95% of Canadian iron ore. So it's a very rich iron ore district with significant infrastructure in place. Iron ore has been mining there, high quality iron ore has been mining in Labrador area since 1960. Around 2 billion tons of iron ore concentrate has been produced so far by this area, by 4 mines usually. Our immediate neighbor is Carroll Lake Mine, owned and operated by Rio Tinto. We are surrounded by mines owned and operated by Champion Iron and ArcelorMittal in our south of us. And the only private company that is operating here is Escoli Mine, owned by private Takura Resources, a US-based company. We have a very large land package, around 150 square kilometers of land. 16 kilometers of iron formation has been identified by geophysics in 8 targets. 3 of the targets have been drilled, and we have an initial resource of 527 million tons in 3 identified pits. Our advantage and significant advantage is access to $3 billion worth of infrastructure. It's a bulk commodity, and access to rail and port is a significant component for success of any bulk commodity project. The other major component is access to very low-cost electricity, which I will be discussing in a couple of slides. The major advantage for our project, though, is having a very high-grade magnetite-rich iron ore deposit with very low impurities. I'd like to draw your attention to some numbers from major iron ore producers globally. MC iron ore mines in Pilbara region in Australia, they're going through a significant grade degradation, and the grade of iron ore has come significantly low from 64.5% in 1995 to around 61% in 2015. For production of green steel using hydrogen, we at least need 67% iron concentrate. And not many mines globally can produce that at the moment. The other example is Brazilian Courageous iron ore mines operated by Vale. Their grades have also come down significantly from 67% in 1995 to 64% in 2015, and much lower now. Our advantage in Lac Virot, and this applies to all mines and deposits around us, is having access to very good, high-quality magnetite-rich deposit. The iron grade in the deposit is not high; it's around 25-7%, but it is highly processable and can be, with a very simple process, be upgraded to north of 67% grade. The other significant advantage of our project is access to low-cost electricity. Again, as I mentioned, steel industry is a very high-intensive energy industry. And now that we are shifting from coal to hydrogen, it is more obvious that access to low-cost electricity is one of the key factors to be competitive with coal production route, with a dirty carbon emission production route. For every ton of steel using sustainable metal using hydrogen, around 104 kilograms of hydrogen is needed. Newfoundland and Labrador, on the other hand, has abundant renewable wind and hydroelectricity, one of the lowest price of emission-free electricity in North America and Europe. The cost of electricity in Newfoundland and Labrador is around 3.5 Canadian cents per kilowatt. When we compare this to some numbers in Europe, I was looking at energy costs, electricity costs in Germany in March 2023. It was 41 euro cents per kilowatt. So our region has significant advantage on the electricity and the cost of electricity, and can be the future of green steel production globally. I mentioned we have a large iron ore resource. We have around 527 million tons of resource, and there's significant potential to explore the area and other 5 targets and significantly increase the resource. The image on the left, you see the biggest iron ore production in Canada, IOC, owned and operated by Rio Tinto, and we're 4 kilometers from our north pits. We're really lucky to be very close to Labrador City. You don't find a lot of mines and operations close to city. Having access to rail, being in the vicinity of a city, having access to port, 12 kilometers from airport, these components will reduce capital cost of the project significantly. And here is our roadmap to the production of green steel. We have basically laid down the project in stages. The hydrogen-based green steel production is currently in pre-commercialization commercialization stage, and significant pilot plan is being conducted globally. Technology readiness is around 6 to 8 and expected to be fully mature and reach commercialization stage by 2030. What we have done is we have adopted a stepwise development approach to reduce the investment risk significantly. What I mean by that is we have divided project to stages. Our first stage, we will be producing green iron ore concentrate with 67% grade, high grade that receives $50 premium at the moment from our nearby mines on top of 62% iron ore cost. The second stage will be installing a pelletization facility, which is basically producing DRI plates. And the third stage of development we'll be installing a hydrogen facility and direct reduction facility. And with these, we will reduce the risk of investment significantly. We also use revenue generated from each phase of development to develop second phase of development. It means that revenue generating by selling high-grade iron ores will be utilized for creating a pelletization facility, and the same approach will be used to produce hydrogen facility and direct reduction facility in the near future. The next slide could elaborate this further. Our first phase of production will produce 2.4 million tons of high-grade iron ore concentrate with 67% grade. The price of iron ore for 62% today is around $108 to $110. So we'll be looking at $50 on top of that, around $150 to $160 current price, today's price for our production. If you do the simple math by multiplying 2.4 to 160, you get an idea of the revenue generated on the first phase with very low capital cost. The second phase of development will be adding a pelletization facility. Again, we'll be producing 2.4 million tons of pellets. And the third phase of development is where we'll be producing 1.8 million tons of green hot briquette iron by using hydrogen. All source of energy for our project is going to be electricity. It is going to be the first green mine that not a single drop of hydrocarbon will be used from extraction, concentration to pelletization and producing green hot briquette iron. The project has significant financial metrics. We have three. In the next slide, you'll see our timeline. But the capital cost we estimated internally based on comparing to similar projects globally is around $300 million. The operating cost for this project and nearby mines, including IOC of Canada, Champion Iron, or other neighbor mines, is very low. It takes around $42. All numbers I'm mentioning are in US to extract and process the iron ore, FOB Port of Seattle, which can generate significant profits and allow us to build the second and third stage of development. Here is our timeline. We'll be looking at 2 years of pre-development, which the proceeds of the capital raising we are doing right now will be spent on doing all the work, all the engineering work, further drilling, doing the permits, which is very streamlined in Newfoundland and Labrador, and basically get to the final investment decision by the end of 2024. By that time, by completion of a feasibility study, we can raise capital by selling the products in advance, by offtake agreements with traders, with steel companies, and raise capital in a fashion to minimize dilution of shareholders but able to get to the production by 2025, end of 2025, 2026. We'll be looking at the stage 2 development there. This approach, again, will significantly eliminate and reduce risk, because there's some technology risk at the moment with the state of hydrogen-based production. We'll wait till later on and make sure that the technology is fully ready for adoption, and we adopt the hydrogen-based production in the future by 2027, by 2028, when the technology is fully mature. The next slide is a business model canvas. I'm not going to spend a lot of time in this slide, but what I like to highlight is our value proposition, which is a significant sustainable adoption of hydrogen as a reduction agent and replacing coal in a full integration approach that enable the green acid production to be cost competitive with the old dirty carbon emission pollutant route that is being utilized at the moment by the industry. I touched briefly on carbon credits, but I'd like to elaborate here a bit further. The output-based pricing system in Canada is basically designed to put a price on carbon pollution for industrialized facilities while maintaining their competitive advantage. If you produce carbon emission more than standard in industry average, you have to pay carbon tax. On the other hand, if you produce a product with significantly less carbon emissions, you'll be eligible for carbon credits. And with our approach, we'll be looking at, as I mentioned before, 3.3 million tons of carbon emission in the future, which can be considered another significant source of revenue for the project. And on the next slide, and the last slide before I take any questions, I'd like to draw your attention that some of the fundings that are available in Canada for us. In the Canadian government, the federal government has around $8 billion of funding for industries that are trying to get away from carbon emission and produce products with a lot less carbon emission, eliminate carbon emission. There are strategic innovation funds that we are tapping onto, and there are job and growth funds. These funds also allow us to do pilot plans, do research, and use some of the funds from these different government vehicles, which, by the way, most of them are non-refundable, to advance the project and make sure we meet all the shareholders' expectations, meet the guidelines, and hopefully get to the production in 3 years. Thank you very much for listening to Red Paramount presentation. And I'll back to you. I'll be happy to take any questions from you or the audience.
Great job, Farzad. Thank you so much. We do have some questions for you. Let's start with, what is the estimated cost of capital for the first phase of development, and how are you envisioning raising capital?
I briefly touched on that. We need to do some work on it, but our estimate based on the benchmarking of other projects is around $300 million for the first phase. I touched on the potential revenue, just simply multiple 2.4 million tons of our production by the cost of high-grade 60% iron ore. So it will generate significant revenue. We will be looking at offtake agreements post completion of our feasibility study. The same approach that Shimanovsky mine, iron ore mine in Ukraine, took a few years ago, but unfortunately the war started and they couldn't advance the project. Offtake agreement is a great vehicle to get capital without dilution and take the mine to operation.
And Farzad, do you have any plans to list an IPO anytime soon?
We are open to that. It is a pre-IPO raise. We are open to keep the company private with strategic investors, or if an investor wants to take it to the public, or we're going to take it to public, we can take the project and the company to public. Right now, the company was previously listed under TSX. We think because it has a green nature and a sustainable approach, NASDAQ might be the better vehicle for us for listing. But again, we need to do some work, at least get to a completion of a feasibility stage to get a better position and valuation when we are listing the company.
And talk a little bit about the permitting process in Newfoundland and Labrador. How long will it take?
That's a very good question. Thanks for that. On May 4, 2023, the Fraser Institute published annual survey of mining companies, and they identified Newfoundland and Labrador one of the top 10 favorable jurisdictions for mining globally. This gives us a huge advantage, and thanks to the government of Newfoundland and Labrador, which they have a very streamlined permitting process. Public, First Nations, and the government are very pro-mining in Newfoundland and Labrador. They're supporting and the permitting. I can mention 3 companies that have gone through permitting recently and have got their permits within 1.5 years, which is significant reduction of time on the permitting if you compare to this in mine development across North America. In British Columbia, it takes years. I know projects in Minnesota in my previous life with Tech Resources and others, seen projects that their permitting process takes 10 years. We've been very lucky to be in Newfoundland and Labrador, and we are in close collaboration with the government to move this project forward.
We have a question from Jim F. When you get to production, who are the customers?
That's a great question. All the steel industries, Eastern US, could be our customers. Because of the Port of Sept-Îles have great access to Europe, we see that with the significant demand in Europe in the future for iron ore, for green iron ore and green steel, we can be producing our products and shipping our products across the ocean to ports in Europe.
And Mark Logan wants to know if you can talk about your valuations of your previous raises. How many raises have you completed, and how have the valuations progressed?
We have done, basically, this is the first time we are raising capital. So I can't really comment on valuation at this stage. The previous work has been funded by the company founders and limited friends and family shareholders. So the company has a very tight shareholder structures. There's no options, no debt, very simple structure, and we'll be looking to discuss with potential investors and come to an agreement with a right valuation.
Greg G wants you to talk about your team and what are some of their successful exits.
Right. So we are going to have significant catalysts if we take it to the public. We'll be going through and producing our PEA reports pretty soon and start drilling in summer 2023. We will be completing a PFS by the end of the year and a feasibility stage report by the end of 2024. As you know, mining companies, as they evolve and they continue completing various stages of development, PEA, PFS, their value increase. So the potential for exiting could be the leap that potential investors could gain after completion of any of these stages. Our timeline to production is very short, it's around 3 to 4 years. So there's significant advantage when we get to the production also.
Wonderful. Well, Farzad, we are out of time, but we've got lots more questions for you. So we'll send these questions to you so you can answer them on your own time. But thank you for joining us on this conference. Great presentation. And we would love to have you back in the future giving us some updates.
It was a pleasure to talk, and great to see you, Anna.
All right. Thank you. Come back again soon.
Okay, thank you very much.
All right, everyone. We'll be right back with our next presenter.